Welcome back everyone, Patrick here. Moving on to the next question. We are given this square-based prism over here. So notice that has a height of x and then it has a length and a width that are the same. So the base is a square and the length is 3x plus 5. And given that, we have to find what is the volume and surface area as an expanded expression. Part B, if the base lengths are both decreased by 7 and the height stays constant, what is the new volume and surface area? And then part C, what is the difference between the base areas of both prisms? So let me erase this over here. And let's start off with part A. Part A, we're just asked to find the volume and the surface area. So let's start off with the volume. Now volume is what? It's length times width times height of a rectangular prism. And even though this is a square-based prism, I like to keep things a little bit general in my head, just so I'm not memorizing too many specific case formulas. So having this be the length, width, height, in this particular case though, the length and the width are just the same thing. So basically the volume of this would be 3x plus 5 times 3x plus 5, so we could actually say 3x plus 5 squared, and then the height is x. If you want to make this look a little nicer, you put the x in front. That right there represents an expression for the volume. Now this is factored over here, but wanted to show this expression first because maybe in a multiple choice test, this would be one of the answers. But we have to provide an expanded expression in this particular case. So expanding this, what I'm going to do is I'm actually just going to work with the two brackets. First, multiple ways you could do this. You could take the x distributed into this bracket and then multiply those two brackets. I'm just going to multiply these two brackets first. Keep the x on the outside. So 3x times 3x gives us 9x squared. 3x times 5 gives us 15x. Then over here we got 15x. And then over here we got 25. And then the 15x, those are like terms. So we'd have x times 9x squared plus 30x plus 25. Like that. And then we could distribute the x inside the bracket, 9x cubed plus 30x squared plus 25x, like that, right after taking the x and multiplying it by everything. So that right there represents the volume of this square-based prism. So the volume, let's write it over here just to keep track, would be that. Now, what about the surface area? Now, the surface area of a rectangular prism, just in general, we're going to have 2 length times width plus 2 length times height plus 2 width times height. Right? Because if we have a length, width, and a height, then we have 2 of the same faces. Now, in this particular case, though, the length and the width, they're actually the same thing. So we can actually represent the length and the width with the same variable. So let's actually change the W, or let's change the L to be a W. So we'll have a W over here instead. We'll have a W over here instead. And so notice what we end up with is 2w squared plus, these are like terms now, 4wh. Okay, and you don't have to necessarily break down a surface area formula like this. You just look at the diagram and make sense of it. So notice that, let's start off with the bases. So the base, notice it's 3x plus 5 times 3x plus 5. And notice that the top face is also the same, right? Because this is 3x plus 5. And then this length is 3x plus 5, right? And there's 2 of those faces, so we'd have 2 times 3x plus 5 squared. 3x plus 5 times 3x plus 5 gives us the area of the base, and then there's 2 of them at the bottom and then at the top. That's why you multiply by 2. So that's where this portion comes from. And then notice that the faces on the side, all of them have a height of x right? And they all have a length of 3x plus 5. And there's 4 of them, right? One, this one in front, this one on the side, 3, and then the one in the back. So there's 4 of those, and each of them have a height, we call it the width of x, right? The width of the rectangles on the side. So all of them have a width of x, and then all of them have a length of 3x plus 5, like that. And then there are 4 of them. So that is the expression for, and then if we combine this 4x, this is the expression for the surface area. And then what we want to do is we want to expand all of this. Now over here, we already know the 3x plus 5 squared. We did that before. That simplifies to 9x squared plus 30x plus 25. And then over here, this 4x we would distribute in the bracket. We'd have 12x squared plus 20x, like that. Then we distribute the 2 in this bracket. So let's actually write it. Actually, let's go over here. And then we got 12x squared plus 20x still over here. And then we have to collect the like terms. So notice that the 18x squared plus the 12x squared. So let's write the surface area over here. Those are like terms. That's going to be 30x squared. So those go away. Then we have the 60x plus 20x. So we would have 80x over here. And then we have the plus 50 at the end. So that there represents the expression, the expanded expression for the surface area. Now in part B, what they're saying is that this square base pyramid now, what's going to happen is the base lengths, they're going to be decreased by 7, meaning that both of these 3x plus 5s are going to be decreased by 7, but the height is going to stay constant. So if we take 3x plus 5 and we decrease it by 7, what do we end up with? Well, notice 5 minus 7 would give us minus 2, and then the 3x still stays there, right? These are the only like terms. And so now the new base length for this new prism is going to be 3x minus 2. And we're going to have 3x minus 2 over here. And then the height is staying the same. So now what we got to do is find the new expression for the volume and surface area. Same process, x times 3x minus 2 squared, x 3x minus 2 times 3x minus 2. Let's work with these brackets first. 3x times 3x would give us 9x squared. 3x times negative 2 gives us negative 6x, positive 4. These are like terms. So we'd have minus 12x there, and then we got a plus 4, and then we distribute that x inside the bracket. So the volume, the new volume, is going to be 9x cubed minus 12x squared plus 4x, like that. Right, so that's the volume. What about the surface area? Well, same thing. 4 of the faces are still going to be the same. This is still a square base prism that we're dealing with. 4 of the faces are going to be the same, and then 2 of the faces are going to be the same, the top and the bottom. So we'll have 2 times 3x minus 2 squared, right? This bottom face has an area of 3x minus 2 times 3x minus 2, and then there's 2 of them, the bottom and the top, and then there's 4 side faces, and all of them have an area of x times 3x minus 2, like that. And so from here, we know that this bracket, it expands to that right there from the last portion. This would be 12x squared minus 8x, like that. And then over here, 18x squared minus 24x plus 8 after we distribute the 2 inside the bracket to all three terms. Yeah, looks all good to me. And then we got the 12x squared minus the 8x over here. And now we could simplify the like terms. So 8x squared plus 12x squared. So let's write the surface area. The new one is going to be 30x squared. So those go away. Then we got negative 24x minus 8x, which would give us negative 32x. Those go away. And then we have the plus 8, like that. So that's the new volume, that's the new surface area. Those are the answers for part B. And then in part C, we're asked, what is the difference between the base areas of both prisms? So remember the base area of the original prism, so let's say the difference in base area, it's going to be the original base area minus the new base area, or actually, I guess it doesn't matter. Let me see, change in base area. We usually do new minus the original, right? But the thing is, the area is going down because we're decreasing the length. So just to have a positive number here, I'm going to say the original base area, which is larger because the lengths were larger for that base. So I'm going to have the original base area minus the new base area. Because they're just asking for the difference. Maybe I shouldn't put change here. They're just asking for the difference. They're not asking how much did, for example, the base area decrease by. So let's just keep this portion positive, quote unquote. But whatever you get here, let's say we got like, it's going to be an expression, but let's say we got like 5 units, for example. You could say it decreased by 5 units, but this portion that we're going to get is still going to be a positive. So what would happen is we'd have the original base area, which was what? 3x minus, or 3x plus 5, rather, squared. 3x plus 5 times 3x plus 5. Minus the new base area, which is 3x minus 2 times 3x minus 2. So that's going to be squared like that. This, we already know, it expands to, we already did it before, it expands to that, right? 3x plus 5 times 3x plus 5 gives us this. And then we're subtracting, when we expand this, we'd end up with 9x squared minus, we did this as well up here, 12x, right? Plus 4. But we're subtracting that whole thing. So you got to make sure you put that in brackets, that whole thing in brackets right there. Distribute the negative inside. Minus 9x squared. So all the signs change like that. And then we just have to get the like terms. So this cancel out, which is nice. And then 30x plus 12x, so let's write this over here. We'll have 42x. Those go away, and then we have 25 minus 4, which would give us positive 21. Right, so that's the difference in the base areas. Right, if you did the new base area minus the original base area, basically all the signs here would be switched. This would end up being negative 42x minus 21. But just to keep this positive, keep that difference as an absolute value, because the original base area was greater, what I did was I just subtracted the new base area, the smaller amount, in order to get a positive expression over here. All right, so that's the original volume surface area, the new volume surface area, and then that's the change in base area.